Welcome back, class. Okay, in this video we are going to take our skills with dimensional analysis to sort of the next level. So if you're watching this video, you're probably new to some of what we're doing here in chemistry with dimensional analysis. And you should have already watched the lessons talking about what a mole is. So if you haven't, please make sure you go back into the playlist and find that video, What is a Mole? And look at that carefully. You really need to understand that because I'm going to be going through that here. I'll be using that, and it's going to help us with that and some basic dimensional analysis stuff that we will be reviewing in this. So I've put multiple layers here to this. So, I've got an A, B, C, D, E. So I've broken this down into some multiple steps, multiple things for us to do. So let's just get started. Let's jump into this. So we have a reaction right here. Aluminum and a solution of copper 2 chloride react. If 2.75 grams of aluminum is added to the solution, determine the following. So there's all these different things here. Now, what is not in the problem is that we want to assume, okay? We want to assume that this particular substance is in excess. It doesn't say that, but in this problem, we have to assume that that is the case. And what we mean is that there's more of this than what is needed. And so with that said, the aluminum would be what we call a limiting reactant. I guess I should write that on the other side. Okay. We would say that this right here is a limiting reactant. Now, we're not going to be talking about limiting reactants in this lesson here, but all that means is this particular substance in the reaction is what determines how much of the product is made. That's really all we need to know for this. If you already know what a limiting reactant is, then you fully understand that. If not, there will be later lessons in labs where you actually have to figure out limiting reactants. But for now, you just need to know that it's very similar to, let's just say you're baking cookies. If the recipe calls for 2 cups of flour and it calls for 1 bag of chocolate chips and all the other stuff that goes with it, and you can make 36 cookies, 3 dozen cookies, then that's great. Everything is used up. But if you only had half of a bag of chocolate chips, then you would now have an ingredient that limits how much of your cookies you can produce, you can make. So you would have excess flour. You'd have an excess amount of flour. So in this case, this example here, the chocolate chips would be the limiting reactant, the limiting ingredient, and then the flour would be the excess ingredient. So you have extra left over. So if you think about it, the amount of chocolate chips determines how much cookie you could make. So the same is here. We're assuming the aluminum is the limiting reactant, and it is determining the amount of products. We just have to assume that in this problem, okay? All right, so let's just jump in. It says, how many aluminum atoms react? So just so you know, this first problem here, we're on A, we don't need the reaction for this. This is just saying, if we have 2.75 grams, exactly how many aluminum atoms is that? All right, well, let's just jump in and do some stoichiometry for that. So this is part A, all right? So we've got 2.75 grams of aluminum, all right? And then what we need to remember is that it's all about canceling out units first. Let's forget about numbers, okay? First of all, you always write down what you're given, which is the 2.75. And then from this point forward, what you're doing is you are just canceling out units until you only have remaining what what is needed. So we've had the unit that's needed. We've had a lesson on ratios, on how to write things from the periodic table or anything at all, how to write it as a ratio. Again, that was in that video, What is a Mole? You may want to go back and watch that if you haven't, so that this would make more sense, okay? So we have to take the unit, grams of aluminum, right? And we need to convert that to something that makes some sense. So we know that we can go from, we're going to how many moles of here? Well, we can go from grams of anything to moles of anything. So, and in this case, we're going from grams of aluminum to moles of aluminum, right? And so in 1 mole of aluminum, how many grams is that? Well, let's go back to our periodic table, okay? And we find aluminum on the periodic table, and there it is, 26.982. We're going to use that 26.98. All right, so 26.98. And now, so we've gone from grams to moles, so notice that unit, it's crossed out. Now we need to go, now we need to convert moles, so you bring down the mole unit. And we can, in one mole of anything, 1 mole of anything, doesn't matter what it is, there are 6.02 times 10 to the 23rd molecules or atoms or ions, whatever the case may be, right? So here we want to know how many aluminum atoms react. Well, if we had 1 mole of aluminum, then that means we would have 6.02 times 10 to the 23rd atoms of aluminum, okay? Remember, a mole is like our dozen. It's always that fixed quantity, 6.02 times 10 to the 23rd. So we're now left with atoms of aluminum, which is what we're trying to solve for. So let's go ahead and just now punch in our information. We got 6.02 times 10 to the 23rd. I like to put that in the calculator first, just to put it to the memory. Now let's see, times 2.75. And I'll just work this whole thing out for you. So that's 1.6555 times 10 to the 24th, and then you can see this right here. That still has not canceled out, right? So that means we have to bring it over, right? So that's atoms of aluminum. And then on the bottom we have 1 times 26.98, so that's still 26.98. Now we simply reduce this fraction, so we're going to divide that answer by 26.98, and that gives us 6.13602. There's a bunch of numbers, right? So I'll just write these numbers down because this is what you're seeing on your calculator. So I want to go ahead and repeat that for you here. So that's still atoms of aluminum. Atoms of aluminum has not canceled out. Okay. So we need to figure out how many significant digits do we need? Well, there's 1, 2, 3 significant digits in that value there. So we can stick with 1, 2, 3 because we divided. So we would want the least total, right? So that's 6.13. There's an argument that says that 6 would round that 3 up. So we could say 6.14. Now this is times 10 to the 22nd atoms of aluminum. I'm going to put a box around that. There's our final answer. So now we have finished A. A is done. All right. Remember, it's all about canceling out those units. Let's move on to part B. All right. Get all this out of the way for you real quick. All right. I'll leave that up there. I'll leave that information up there for you. How about that? All right, so now let's work on B. How many moles of aluminum are used in the reaction? All right, well, this is just a very simple problem. 2.75 grams of aluminum, right? And so we already know that's 26.98 grams of aluminum per one mole of aluminum. All right, cancel out grams. All right, and we already have the unit we need: moles of aluminum. Moles of aluminum. It's what we want, right? So now we just do our math. So this is on top, we get 2.75, and then moles of aluminum still has not been canceled out yet. So this is effectively what our problem is right here. 2.75 divided by 26.98, and that gives us 0.101927. You don't need to write all of these. Just write extra numbers. But I'm just writing them all because for learning purposes, I know for some of you, it's important if you kind of see everything happening. Again, 1, 2, 3 significant digits. There's our first, there's our second, there's our third sig fig. This 9 definitely would round that number up, so we would say 0.102 moles of aluminum. And if you think about that, that makes sense. We're just, because it's a fraction of it, right? I mean, 2.75 is a fraction. It's a percentage, and it's a very small percentage of 26, right? Okay. Pardon me, I had to yawn. I think I need a cup of coffee. All right, let's move on to part C. All right. Wonderful thing about videos, you can pause, rewind, and look at each lesson as many times as you need to make sure you get it. All right, how much product will be made in the reaction? Okay, now here is where we need to do. Here's where we need to do a little something different. We actually need a reaction to do this. So this is aluminum and copper 2 chloride, and it's a solution. So aluminum, well, aluminum is a metal, like aluminum foil, right? That's a solid. Aluminum plus copper 2 chloride, so that's copper 2 chloride, and it's a solution, so that would be aqueous. Those two are going to react. You should be able to see that this is a single replacement reaction that would form copper plus aluminum chloride. Copper, of course, is a solid. And then the question is, the aluminum chloride, what phase would it be in? Well, we can go back to our solubility rules, right, that we have right here. And we see that solubility rules, so we want to know the solution of chloride. So chlorides are soluble, except when they have silver, there's mercury 2, and lead 2. Now, we don't have either one of those cations in this compound, so it's soluble, right? So I can back all that up. I want to always walk away from this kind of with a clean slate. All right? So we know that this would be an aqueous solution. All right? And then we see from here, this is not a balanced reaction. You can see that there's 2 chlorines on the reactant side and 3 chlorines on the product side. Well, what's common between 2 and 3 is 6, so 3 times this 2 would be 6 chlorines, and then 2 times this 3 would be 6 chlorines. Chlorines would be balanced. Now we have 2 aluminums on this side, so we need 2 aluminums on the reactant side. We have 3 coppers over here on the reactant side, so now we're going to need 3 coppers on the product side. Now we have our balanced reaction now, okay? All right. So let's see what we got here. How much product will be made in the reaction? Okay. We have 2 point, here, let me get a different color just so you can, just to keep everything separate for you. We have 2.75 grams of this. The question is asking us how many grams of product is made. Well, that's a product, and so is this. Okay? So we have actually two parts to C. There are really two things we're trying to answer for in C. So here's a little pattern that you can follow. It's not a trick. This literally is what you do to get from one answer to the other. Excuse me. To evaluate, I had to yawn again. I really need a cup of coffee. This is what you have to do to evaluate or to figure out the problem, to determine the problem. We're going to go from grams to moles. We're going to go gram to mole to mole, and then mole to gram. All right? So notice I followed a pattern. You're going to go from the gram unit to moles, and the coefficient is always the mole. And then from moles, you're going to compare that to moles of what you're trying to determine, and then from moles of that to grams of that. All right? So it looks a little messy, but I promise you this makes sense. So I'm gonna write out a pattern for you. This is helpful. I would write this off to the side so that when you see this happening next, you'll understand this. So X amount of whatever we're gonna call A. All right. So we're gonna call this right here substance A, and this copper, the first thing we're gonna solve for, we're gonna call that substance B. Why A and B? Because I don't want to call it X and Y. That is why. I'm just deciding to call it A and B. All right. You're not going to necessarily see this in a textbook or anything. So don't worry about numbers. Remember, there's grams. We need to go from grams to mole. So you'll remember that you heard me say grams to mole. And we're going to go grams of A, right, which is right there, to moles of A, which is right, which will be this substance here. I didn't mean to circle the two. We're going from grams of A to moles of A. In this case, A is our aluminum, but don't worry about that right now. So you've got grams to moles, and then mole to mole, and then mole to gram. So now we're going to go grams to mole, mole to mole, mole to grams. Okay? It's the same pattern. I'm just trying to point this for you. So now we've got moles of A to moles of B to grams of B. So now let me try to recap this again. That may have been a little confusing if this is your first time. All right. Doesn't matter what your reactant, what your products are. It doesn't matter. I picked aluminum because this problem is talking about 2.75 grams of aluminum. So that's why we're picking aluminum as A. We're picking copper as B because that is what we're solving for. All right, so we always go 1, 2, A, B. So notice you heard me go grams to mole, mole to mole, mole to gram. It's all about canceling units. We're going gram to mole, mole to mole, mole to gram. Okay. Your math teachers have taught you if you have the same unit on the top and bottom, they cancel out. So we have the same unit on top and bottom, top and bottom. Now the only thing left is grams of B, which is what we want. So this is the pattern that you essentially follow when you are given the mass of something in a reaction to figure out how much of something else is either used or made in the reaction. You can always follow this right here, okay? So now I'm going to erase this off the board because I need this space right here to do some writing, but you should have this written down on your paper so you can follow along with what I am getting ready to do. All right? All right. Let's figure the first one out. We've got 2.75 grams, and I'll put that back in white. I'm going to try to stay consistent for you. 2.75 grams of A, which is the aluminum. We're going to go grams of A, which is aluminum, to moles of A, which is also the aluminum. We already know the molar mass. 1 mole of aluminum is 26.98 grams. We know this already, and we see that that cancels out that unit. Okay. Now bring this unit down. Moles of A to moles of B. Well, we can see here that there are 2 moles of aluminum for every 3 moles of B, which is our copper. Okay? Moles of aluminum cancels out. We're going to bring down moles of the copper, and we can convert that to grams of the copper. This is moles of B, grams of B. Okay? 1 mole of copper, we go back to our periodic table, we find copper, and we can see right there 63.546. Let me slide that over for you. 63.546, so we'll go with 63.55, right? So that would be 63.55 moles of copper, it's gone. So now at this point, we just need to do a little bit of math here. So we multiply across the top, multiply across the bottom, reduce the fraction, evaluate it, and then we're good to go. So we've got 63.55 times 3 times 2.75, right? And that's what, 524.2875. And then grams of copper, you can see right there, still has not been crossed out, so you have to write it. On the bottom, we have 2 times 26.98, right? So that's 53.96. So now we have to just reduce this fraction, 524.2875 divided by 53.96. That's 9.171622. There's a whole bunch of numbers, but at this point, we don't need those. We just need a few extra to help us evaluate this. 3 sig figs, 1, 2, 3. That 1 after the 7 will not round it up, so we're looking at approximately 9.17 grams of copper. That's how much copper would be produced in this reaction. Okay. All right, let's do this again for now the aluminum chloride. Let's go ahead and let's erase all this. All right. Here we go. Start off again with what you know. In this case, B is going to be this substance. We've already figured out the copper. So we've got 2.75 grams of the aluminum, right? That's what we're starting with. And grams of aluminum, 2 moles of aluminum. 1 mole is the 26.98 grams. We've been using that the entire lesson. Grams canceled out. Grams of aluminum canceled out. So now we can go from, we've gone from grams to moles. Now we're going to go mole to mole. So that means we're going to look at moles of aluminum to moles of aluminum chloride. So we're going to go moles of aluminum to moles of aluminum chloride. So we can see here that there's 2 moles of aluminum for every 2 moles of aluminum chloride. Well, this is fantastic. Not only does moles of aluminum cancel out, but 2 over 2 cancels out, so we don't have to worry about those numbers in our calculations. It just makes the math even easier. All right, you could leave the 2's there if you want to, but just don't forget to use it on both the top and the bottom. I'm going to cancel it because we just don't need it. All right, now I'm going to bring down moles of aluminum chloride, and we're going to convert that to grams of aluminum chloride. And 1 mole of aluminum chloride, so we would count 1, we would get the mass for 1 aluminum and 3 chlorine atoms, right? Well, 1 aluminum is 26.98, right? Plus chlorine is that 35.45, and then that would be times 3. And that gives us 133.33 grams. Moles of aluminum chloride cancel out. All right, so on the top, we've got 133.33 times 2.75. That gives us 366.6575. And then grams of aluminum chloride have not canceled out yet. On the bottom, it's just the 26.98. Everything else, all the units are gone. Everything else is gone. No more numbers, units, nothing. So the 366.6575 divided by 26.98, we get 13.58997 and a few other numbers that we don't need. That's grams of aluminum chloride. Once again, 1, 2, 3 sig figs, 1, 2, 3, and there's a very strong argument that says that 8 will round that 5 up, so we're going to go with 13.6 grams of aluminum chloride. All right. So now let's think about this for a second. So 13.6 grams of aluminum chloride, and then we had, over 9 grams of the copper that were made. So if you look at those numbers, pardon me, that's higher than 2.75. Well, that makes some sense. If you look at the periodic table, look at our reaction. We're starting off with aluminum right here. And aluminum is 26.98. Copper and chlorine, by contrast, all right, copper is that 63.55, chlorine 35.45, and there's 3 of those. So if you think about it, it makes sense that much of the mass that we're calculating for is right here in the excess reactant. So however much is needed, however much is actually used in the reaction is being used and combining with the aluminum over here like this. But again, these have more mass, and so it makes sense that the mass of these products is more. So the mass of this excess reactant here is much greater than the mass of the aluminum here, and so that makes sense why we're getting these larger numbers. Okay, just wanted to point that out in case anybody might be confused about that. All right, let's erase all this right here. This is messy. I'm going to clean this up and kind of start fresh again. All right. So that was C. D. How many moles of product can be made in a balanced reaction? All right, well, let me put the reaction back up here. So there's a solid plus our aqueous copper 2 solution. and then it would form some solid copper that would precipitate out, and then we would have our, wow, that's pretty messy. Then we would have our aluminum chloride solution as well that is formed, right? And then remember, we needed 3 times those 2 chlorines, 2 times these 3 chlorines, so there's 2 of these, and 3 coppers. Okay, so now, let's think about this for a second. How many moles of product can be made in a balanced reaction? This is a generalized question. It doesn't matter if we start off with 2.75 grams, 275 grams. It doesn't matter. It's just asking generally how many moles of product can be made. In this reaction, you're going to see, you see that there's, in this balanced reaction, that there's 3 copper and 2 aluminum chlorides. The coefficients tell you the number of moles. So the answer to the question is, I don't know, there will always be a ratio of 3 moles of copper, because that's what this is, to 2 moles, oops, I hit that out all the time, of aluminum chloride in a balanced reaction. Between these substances. Okay, I mean, I'm just making this up as I go. And there's multiple ways to word this, but the most important part is there's a ratio of 3 moles of copper to 2 moles of aluminum chloride. That's the most important part of understanding D. Okay, so that was easy. Let's move on to E. How many moles of product are made from 2.75 grams of aluminum used in the reaction? We actually answered this problem earlier when we were calculating C. It's just that we took it one more step further. All that dimensional analysis, that we call stoichiometry, by the way. So all of this fancy stoichiometry, and this is pronounced, again, stoichiometry. Stoichiometry. I don't know. I'm making this up as I go. I've never actually done a phonetic breakdown before. Stoichiometry. All right, that's how you pronounce this word. And it's a fancy way of saying we are analyzing these reactions for the relationship between the mass of reactants and products. That's it. That's kind of that is essentially what we're doing here. All right. All right. So E, how many moles of product are made? Well, let's start with our 2.75 grams of aluminum. This is where we're going to say, okay, here is A and here's B. So we've got grams of aluminum, 2 moles of aluminum. And so this is 26.98 grams for every 1 mole of aluminum. And then in this reaction, again, we see that there's 2 moles of aluminum for every 3 moles of copper. Cancel that out. We're done. We just want moles of product, and there's moles of that particular product. So we can stop here and go 2.75 times 3. All right. 2.75 times 3. All right, we get 8.25, and then that's still moles of copper on the top. 26.98 times 2, and that is 53.96. All right. So now 8.25 divided by 53.96, that is 0.15289,103. Don't need all of those, but just for training purposes, I'm writing them all down. 1, 2, 3 sig figs, 1, 2, 3 sig figs. This 8 will round that 2 up, 0.153 moles of copper. There's the first part to E. Now we just have to do the same thing for that right there. Okay. So let's give it a shot. Now this becomes our B. 2.75 grams of aluminum. Okay, so grams of aluminum, 2 moles of aluminum. And this time I'll just worry about the getting all the units canceled out before we worry about the numbers. And then we're going moles of aluminum. This time 2 moles of aluminum chloride. Grams of aluminum cancel out. Moles of aluminum cancel out. 26.98 grams for every 1 mole. And in this reaction, we can see there's 2 moles of aluminum for every 2 moles of aluminum chloride. Once again, don't worry about those 2's because the same value on top will cancel out. So essentially, this is 2.75 moles of aluminum chloride for every 26.98. There's no other units on the bottom. They've been canceled out. So that's 2.75 divided by 26.98. That gives us 0.101927, blah, 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 blah. There's a bunch of other numbers. We don't need them. We just need a couple extra to evaluate our answer. 1, 2, 3 sig figs. 1, 2, 3 sig figs. That 9 definitely would round that up. 0.102 moles aluminum chloride. And we're done with E. We have now answered every one of these questions. A, B, and C are us. A and B are us looking at just basic dimensional analysis with basically using Avogadro's number, the concept of molar mass, a basic mole, etc., and that type of stuff to figure out how many pieces and parts we got. In C, we needed our balanced reaction to be able to make a prediction, and again, we assumed we had excess of 1, and so the other was what we called our limiting reactant. And then D, we just need to look at the balanced reaction itself, and then from there, the coefficients let us know the number of moles of everything. And then E, how many moles of product? It's just like C. We just stop at the calculation of a mole instead of going one step further to the calculation of grams. We just stop at the mole calculation. All right. It's a lot to take in, but you should hopefully see that all the math that's here is exactly like the math that you have to do just with basic fractions. All right, just from converting units of measurement. All right, basic units of measurement like time or distance or anything else like that. If you haven't already, check out that video and refresh your memory if you need to and take some notes, or reach out to me. I'll be happy to help. Always good to be able to be here for you. Reach out if you need something. Stay curious, and I will see you in another lesson real soon. Bye.